Welcome, there is Motion Technical Support. Here is the 7th part, how to connect Z Motion Controller with Z CAN Bus Expansion Module. As usual, see what we need firstly. Please prepare these materials. It can be seen there are 2 power supplies this time. One separate power for I/O. Then it can prevent I/O signals from interference well. And it also should be 24 volts DC power. Specific information about wiring will be talked later. Before the connection building, let's see what's the function of expansion module. When some resources of controllers are not enough, expansion modules could supply them. Generally, expansion modules can expand digital I/O, analog I/O, and pulse access. But please note the pulse access expansion. It is only valid in expansion module that is with pulse access interface. For expansion modules, there are 2 types: EtherCAT expansion module and CAN expansion module. And according to this, ZMotion provides 3 kinds of expansion modules: Z CAN expansion module, EtherCAT expansion module, and ZMIO310 series expansion modules. Then, how many resources they can expand? Usually for ZMC4 series motion controllers and above, 4,096 digital inputs and outputs, 520 analog inputs and outputs can be achieved. For Z CAN bus expansion modules, for pulse access can be extended at most. If it is still not enough, please select controller with more pulse access, or use several modules, but it is not recommended. And these information can be checked through the hardware manual or through questions StartMax command in ZDevelop. The former 1 means the number that is supported by controller itself. Behind 1 means the max number that can be expanded. Today, we mainly talk about Z CAN bus expansion module. It has 2 product series: Z CAN expansion module and ZMIO310 CAN expansion module. CZ CAN expansion modules firstly. There are several typical products. ZIO1616MT. It supports 16 inputs and 16 outputs of NPN type. ZAIO0802 is used to expand analogs, 8 analog inputs and 2 analog outputs. ZIO16082 is used to expand digital I/O and pulse access. That is 16 inputs, 8 outputs, and 2 pulse access. ZIO1632 means 16 digital inputs and 32 digital outputs. If it is MT, which means the cover is broad. ZMIO310 CAN is a kind of vertical expansion module, which supports digital iOS and analog expansion. And here, it shows Z CAN expansion modules type. Use according to your specific needs. It can be seen 16 inputs and 32 outputs at most, and only 2 pulse axes can be expanded for 1 module. Please note not to use too many pulse axis expansion modules. 2 is the most. For others, several are okay. And someone might see, there is one ZO1616 PNP. It means PNP type. Generally, if it without PNP suffix, NPN type is default. For analog, ZIO0802, 010 voltage, and the resolution is 12-bit. Next, see wiring. Here is the CAN bus terminals. There are 5 ports: power supply, CAN H, earth, CAN L, and G and D. When there are several CAN modules connected, please connect CAN L to CAN H of all modules together correspondingly. And remember to dial the 8 bits of the last module as on, which means connecting one 120 ohms resistor between CAN L and CAN H. CAN communication, it should ensure that corresponding G and D are connected, or use 1 power for controllers and modules. ZL modules use dual power. Please separate them. ZIO modules use single power. Only main power is needed. Let's see one example for clear. Here, take ZMC432, Z01608 and ZIA IO0802 as the example. Cable with shield layer is recommended. Main power of controller and power sharing 1. For I/O power, ZIO1608 I/O needs to be powered independently. Connect all CAN-L terminals together and connect all CAN-H terminals together. Set DIP switch well. Their DIP ID can't be the same. Dial the bit 8 of ZIA IO0802 as on. Next, see the second CAN bus expansion module, ZMIO310 CAN. It is vertical module. It combines one communication module with several in and out modules, and submodules can be these. Also, there are NPN and PNP, and in, out are with, signal state LED. For these two digital out modules, they need to be powered separately. For analog, it can be current type or voltage type. Default voltage is 0 to 10 volts. Resolution is 16-bit. Then the same, see the wiring. Actually, they are with the same wiring method and same DIP settings. From now on, we talked about what expansion modules are and the functions, but how to use. Before using them, expanded resources must be mapped into controller local resources. This can be called map. There are iOS mapping and access mapping. For I/O mapping, use dip switch settings that is brought with expansion module. For access mapping, use the access address command to map access numbers. However, even if different CAN modules, they use the same mapping methods. This is the DIP switch. It can be seen there are 8 switches, on or off. 1, 2 for CAN ID. They are for I/O address mapping. The values are 0 to 15. 5 to 6 are CAN communication speeds. The values are 0 to 3, which means there are 4 kinds of speeds. 7 is for reserved. 8 means 12 0 ohmega resistor. Let's see one by one. 1, 2 for our 4 CAN addresses. According to this dialed address, controller will set corresponding expansion module I/O number range. Dial as off, value is 0. Dial as on, value is 1. Then address combination value is dial code 4x8 plus dial code 3x4 plus dial code 2x2 plus dial 1. And follow the rule from binary to decimal. Dial code 4 is the high bit, code 1 is the low bit. It can be seen it starts from 16. I/O range is 1631. Please attention dip switch must be set before power on. For analog I/O, CAN address also is set by dialing 1 4. For analog input, it starts from 8. For analog output, it starts from 4. Actually with same method as I/O. 5 to 6 for CAN communication speed. The value is from 0 to 3. For speeds are here. Speed combination value equals to dial code 6 by 2 plus dial code 5 by 1. For speed communication, controller and CAN expansion module must be with the consistent speed. But how to set it for controllers? Through the CANio address command. This instruction also can set CAN communication master and slave station. Default value 32 means master station. Before or after settings, it can be checked through controller status in DevLop. During DIP switch settings, there is one note. The dialed value must be more than the larger one between in and up. Except the external iOS number, iOS impulse axis also should be added. For example, one controller has 28 in and 16 up. Then, the starting address of the first one expansion module should more than the max value 28. The address combination value should be 1. Then I/O number of expansion modules is 32 for 7. 2931 can be omitted. And when iOS numbers repeat, only 1 is valid. At this time, please reset. Okay, that's all for I/O mapping. Let's learn how to use expanded access. Before that, do access mapping. For CAN bus expansion module, using ZIO16082, it can expand to pulse axes. As we mentioned before, axis mapping and IOS mapping use the same method. And also it uses the axis address command. And this shows the mapping rule. Among them, ID is the combination value of expansion module 1 to 4 bits. After mapping, set basic axis parameters. Then you can use expanded axes. For example, it can be seen the ID is 2. That is, map axis 1 of expansion module as axis 6. Set axis type as ZCAN expansion axis. Then other basic parameters. See examples. Here shows example of ZCAN expansion module. 1 motion controller ZMC for 3.2 and 3 expansion modules. At first, do wiring for them. It can be seen there are 2 powers, main power and I/O power. All CAN L are connected. All CAN H are connected. Then, set the IP switch correctly. Next, use ZDevelop to connect to controllers. Namely, we can read all device information in ZDevelop's controller status window. Please see this. ID of ZIO1632 is 1, and there are 16 expanded digital inputs and 32 expanded digital outputs. For ZIO16082, the ID is 3. There are 16 digital inputs and 8 outputs, and it is with 2 pulse axes. For ZIO0802, the ID is 4, 8 analog inputs and 2 analog outputs. Example of ZM-IO310 CAN expansion module. 1 controller ZMC432. 1 ZM-IO310 CAN communication module. For ZM-IO31016 D input submodules. To ZM-IO31016 DO output submodules. To ZMI-O3104AD and to ZMI-O3104D modules. Also, connect to controller through ZDevelop. Open controller state window. It can be seen the ID is 1. There are 60 for expanded digital inputs, 32 digital outputs, 8 analog inputs, and 8 analog outputs. As mentioned before, ZDevelop can be connected to check ZCAN information. Actually, there is another method to see whether expansion modules are connected successfully or not. That is, through CAN IO state. Use if or enter it in the output window. Value 1 means success. Value 0 means failure. Okay, next, let's see the ZCAN expansion module routine in ZDevelop. Power on controller. Connect to controller. Download the program into controller. Then the program will execute. CAN enabled first. On is default. Then set master or soft station through CAN IO address. Default is master station. And default value of CAN baud rate is 500. Corresponding speed combination value is 0. If you need other values, please refer to these 3. Then delay 300 milliseconds. Next, see expansion modules connection states. This one means ID. Connected, then do axis mapping for expansion modules. Set axis types as virtual axis. Map axis 0 of ZIO16082 as axis 6. Map axis 1 as axis 7. After that, now it sets the axis type as 8. ZCAN expansion module pulse type. Then set corresponding axis parameters and motion commands. Use move up to control expansion module output. 40 means out number on ZIO1632. 64 means out number on ZIO16082. 20 means out number on ZIO0802. And in ZDevelop, view up window can check out information. For all ZCAN node information, refer to controller state window. It shows clearly. Okay, that's all for today. See you next video. EtherCAT expansion module. Have a nice day.